Hey everyone, Mr. Gimson here, and today we're going to be learning about the zero index. I've got some new headgear to rock with, so hopefully you guys enjoy it. When we're looking at index laws, remember how I talked about how there's this idea that we can just sort of give you the rule, and that's all well and good, and I will give you the rule of how the zero index works. So when I have something to the power of zero, what's that going to look like? But I still think it's important that I give you some intuition or a bit of an understanding of why these work in the way that they do, right? And the way I'm going to use these existing index laws which we've already established, okay? Just as a hint, anytime we roll with something with zero involved, for example, when we multiply by zero, the result is zero. And so you may think that that's what's going to happen here. It's actually not. And let me show you why. Because let's give an example. Let's say, let's use a numerical example because hopefully that's a bit clearer. Let's give you 2 squared divided by 2 squared. Okay, what does that look like? I want to write that as in a fractional sense. So that's 2 times 2 divided by 2 times 2. Right, and that's just 4 divided by 4, which you know when you have something divided by the same thing, that's just 1. But what I can say is that when I have these indices where I'm dividing them, I can also write it using this index law here. I can say that that's 2 to the power 2 take away 2, and actually that's 2 to the power 0. So hopefully you can see now, this is actually what my value will be. When I raise something to the power 0, it's actually going to equal to 1. And you can show that that works true for any base. It doesn't matter which base you do. If you have 50 to the power 0, you can have 100 to the power 0, you can try on your calculator. It's always going to equal to 0, right? Let me show you another way of showing this. So last time we sort of talked about patterns. So if you remember, we sort of established this pattern where when we go up in powers, or base 2 at least, we're just doubling the number, right? Which begs the question, what's happening when I go backwards? Well, I'm just dividing by 2. And so what happens when I divide by 2 again and I reduce this power by 1? Well, for 2 divided by 2, that's just 1, right? So there's 2 ways of thinking about it. You can think about it like using one of the existing rules you've done, or you can think of it like a pattern. Regardless, the result is the same. Anything to the power 0 is equal to 1, with one exception. There's always exceptions to the rule. This does not work when a is equal to 0, okay? So in this situation here, 0 to the power 0, that does not apply. The question is why? That's a question, good question for another time. But really, for the sake of convenience, we don't typically define 0. Because remember, there's problems with 0, right? Because what does 0 to the power 0 even look like? Because usually when you multiply 0 by anything, it becomes 0. So how could it just become 1? It's a bit tricky to just sort of define that, right? We'll leave that one for now, and we'll come back to some examples first. All right, so here's some evaluate questions. Remember, what does evaluate mean? It means I want a number, a numerical answer at the end, okay? So it doesn't matter what variable I have or what number I have, t to the power 0, that's just equal to 1. And be careful with these here. This is xy all to the power 0 in brackets, right? So xy all to the power 0. Because that whole thing is in brackets, then we can say that that's also equal to 1. This one's better, you can put in your calculator. 17 to the power 0, that's equal to 1. This one though, you may be wondering, how do they make these harder? It can't just be 1 all the time. And the way that they try and make these a bit tricky is, notice the difference between these two. This one has brackets, so it's saying this whole expression is raised to the power 0. This one is only associated with the x variable. So what's actually happening is you have 5 times x to the power 0, right? Which we know is 5 times, what's x to the power 0? That's just 1, right? And so that's how I know that that's actually equal to 5, because the 0 is only attached to that particular base. So that's something you want to be careful of and look out for, is questions like these, yeah? Same thing here. This one's a bit different again, because actually now the 5x is inside the bracket, so that's equal to 1. But now I have this 2 here, so that's how I can evaluate to get 3, okay? And last but not least, same thing. Doesn't matter what values, what bases, what variables. All right, all of this, anything to the power 0 except 0 is equal to 1. So I'm going to get 1 plus 1, which is equal to 2. And that's it. That's the 0 index. How good is that? Hope that made sense. Let me know if you have any questions. Drop a comment below.